I heard gruz was the word I heard, but I don't know what it's supposed to mean. If it's super inappropriate, please tell me. Uh,
Huzz? Oh my.
It's the grandma huzz. That's what she.
It's like.
we'll cover that in a minute. All right. So secant of theta is 3 halves. I'm asked to solve this using a physical triangle on my page, so we're going to make that work. We have a few options. I'm really only worried about sine, cosine, and tangent, but let's think about this. Secant is the reciprocal function of what? Cosine is what I confidently heard whispered. Cosine is adjacent over hypotenuse, so that means if you flip it, instead of adjacent over hypotenuse, this is probably going to be hypotenuse over adjacent. Everybody cool with just that logic? There is a 0% chance, unless I was told to draw a triangle, that I would really ever draw a triangle with these. They're not truly needed, but it's nice to formalize that idea with geometry in mind. So I'm going to sketch a triangle. Am I paying any attention to the scale? Not even a little bit. Like 0% of me is worried about the scale. It might be super annoying. I don't care if it annoys me. You might care if it annoys you. I don't care if it annoys you. Cool. Well, what gets what? The hypotenuse, we know its length. 3. And which of these is adjacent? Ooh, I don't agree with you. The one on the bottom, it has to be touching theta, but it can't be the hypotenuse. So that's a 2.
You could just put theta in the top right.
You could.
Yeah.
Absolutely.
So then it could be.
Then it would switch. But from the second I commit to this theta, I can't. Okay. How do I find that other side? The Pythagorean theorem. Now, I'm not going to write it down. Can you guys tell me what 3 squared is? And then what's 2 squared? So in my head, I already have something squared plus 4 equals 9. So something squared, then when I subtract it, is equal to 5. I think that's root 5. Did I lose you on that? If I know that a squared plus b squared is c squared, then I think it's reasonable to say, well, I know that a squared is just c squared minus b squared. And then I just took the square root. I'm just rearranging it. Okay, we have all 3 values. This is, if you found these problems hard, this is the only hard part of this problem. So I'm going to be crazy and just list them out in the same order all the time, every time. Sine, cosine, and tangent. And then, since we're doing it, might as well. Cosecant, secant, which I already know that one.
Why don't you put secant first? Is it, oh, is
It's
which one-
so annoying. Sine and cosecant match up.
Those are the ones that correspond.
Those are the ones that correspond. Those are reciprocals.
I got a few wrong.
It's super irritating. But it's stuck. So, not my choice. I cannot. I don't know why that one has the parentheses. All right. Right off the bat, this was the one that was given. 3 halves. And I have a triangle in front of me to think about. Let's check. If I want the cosine, for example, I already know what it should be. I'm pretty sure. But cosine from this angle is what? Cosine is adjacent to? Could I have done that without the triangle in front of me? 100%. Okay. Sine gets a little bit harder, but it's nothing too crazy. It's easy with the triangle. Sine would be what? Love it. Opposite over hypotenuse. Looks like a root 5 over 3 to me. Now, I'm just going to say the algebra, if you need to write it down, feel free. You can rationalize, fix the radicals. This is what when we flip it? So 3 over root 5, and I'd never leave it like that. 3 root 5 over 5 is how it will rationalize. Cool. Tangent. Opposite over adjacent. What does that give me on this one, JV? For this triangle. Tangent. Okay, and then this would be 2 over root 5, but I'll rationalize that to be 2 root 5 over 5. We're done. Don't touch your calculators. Unless you're doing a specific, if you do it to square or add, whatever, I don't care. Never give me the approximations. 100% answers unless specifically it's going to be awful if you give me the exact answer. Like if you tell me to cut a piece of wood that's root 5 over 2 units long, that's dumb. Don't do that. But if I'm just asking about the number, do this. Keep it here. Cool. All right. I'm going to add a few problems to that here in a few minutes. Don't hand it in yet. Everybody feel okay here? Baller. Let's do a couple more. And I'm actually only going to add a few problems. Today's going to be weird. I'm going to lecture for like 10 minutes or so. You guys will have 10 minutes or so to do a few more problems, and then we'll kick back into doing some word problems. Cool. All right. So one of the neat ideas that we started to kind of allude to yesterday, but have not been able to finish, and I'm going to make a new layer here. Boom. Okay. One of the things that we started mentioning yesterday is these things that are true for any angle theta. All of those equations that we saw yesterday that are true for any angle theta, they have a name. We saw the reciprocal somethings, the quotient somethings, and the Pythagorean somethings. What are the somethings that I'm referring to? Not theorems. Something that's true for all angles theta, no matter what. Is this yours?
Yeah.
Identities. They are the identities. Now, identities are true forever, always, like for any angle. Now, as we're looking at it, one of the really cool things that we're going to be able to do, and we did one example using identities yesterday in our notes. That's the last thing that we did. I want to look at just one more of those and then a fun variation of something like that. So, in your notes you had example A, right, where I gave you some stuff. I want you to knock out one more for me, and I'll give you a head start, and then we'll chat about it. I want theta this time. We'll let theta be in quadrant 3. Okay. Right off the bat, theta is in quadrant 3. Beyond that, I'm also told that for whatever this is, the sine of theta is negative 4/5. And all I want us to do is just one of these. I lied. I want us to find two. I want us together to find the secant of angle theta and the tangent of angle theta. Okay. There are a few different ways that we can knock out problems like these. Do we want to draw the triangle? Might it help? Definitely. Some of you, it will for sure help. Some of you, maybe it won't be as big of a help, but that's okay. We're going to use it anyway. So if I wanted to sketch this, and I do, and I want you to, at least for this one, I want you to sketch it on your page first. I'm going to come around and be really judgy. Cool. Sketch me this angle theta. It doesn't have to be perfect, but I want you to sketch the angle theta and the triangle that it forms, and I'm going to come check it out. Right off the bat, if I want to sketch this, and I want it to truly be represented by all this information, there's one part that's super annoying. First off, which quadrant? Third. So all I'm going to do is say, hey, it ends up over here. Now, is that the hypotenuse of a triangle, the opposite side or the adjacent side? I haven't even drawn a triangle yet. This is my hypotenuse. I want to make this a right triangle because that's the right triangle trig that we're using. From here, where should I go to make my right triangle? Straight up. Bow ties and butterflies. Now this part's super duper annoying. And I get it. Physical triangles, if I said make me a triangle whose length is -4, could you do it? I can't make a length of -4, not in reality, right? But as we're looking at it, sine is opposite over hypotenuse, right? So my angle of this right triangle, my acute angle that we're dealing with, this is the angle theta that forms this triangle. This distance is really and truly 4. Why is it written as negative here and here? It's in the third quadrant, and sines are y values over the radii. Now, one issue, and this is, it's just strange when you think about actual triangles. If my hypotenuse were negative, then negative over a negative would have made that sign positive, right? My hypotenuse cannot be negative. It can't be, and I know that it won't be because we can obtain its length by the Pythagorean theorem, which is a square plus a square, never going to be a negative number. Now, looking at it, this is 5. Now, To get the other side, how many of you guys actually straight up use the Pythagorean theorem? Okay, we're going to add a little thing here just off to the side. I want you to have this. It is not 100% necessary, but it will save you time. We're going to look at what we call Pythagorean, and I'm just going to shorthand Pythag triples. Okay, these are shortcuts. I refer to parents and children constantly, and you'll see why that works out here. The easiest Pythagorean triple that I know of comes in the following ordered triple instead of an ordered pair. It is 3, 4, and 5. I call this a Pythagorean triple because if you take those first two digits, 3 squared and 4 squared, they're equal to the third digit. This is a Pythagorean sides of a right triangle. These three side lengths satisfy the Pythagorean theorem. This is a parent. Now, pretty sure it's a biblical thing. You guys ever heard, just finish a phrase if you know it, be fruitful and something? Okay, maybe not. Multiply is the word that I was thinking of. I think it's biblical. I don't know. Maybe not. I have no idea. Could this parent have a kid? Like it multiplied? Could you multiply by 2? Which means if it got multiplied by 2, this would be a 6, 8, 10, right? Could you multiply it by 5 or 10 or 13 or 1.7? From this one Pythagorean triple, how many children are there? Infinitely many. I don't know all infinitely many of them, but I do know that 3, 4, 5 makes a right triangle. Okay, other ones that I have, and I legitimately, I think, I'll see if I can remember another one. I only have 2 off the top of my head. This is a parent, 3, 4, 5, every time. 5, 12, 13 is another parent. 5 squared is 25. 12 squared is 144. Those together make 169, which is 13 squared. There's another one that has 24 and 25, and I think it's 7. Can somebody verify for me? Calculator, do 7 squared plus 24 squared. And you, Barsega, do 25 squared.
625.
And it's definitely going to be 625. So there's a third parent that I remember. It is 625, right? 25 squared? Okay. Now, turns out there are infinitely many of them. These are the only ones that I remember. But I use this all the time without any thought. As soon as I see 4 and 5 here, well, there's a triple with that. Guaranteed it's 3 right off the bat. No thought needed. I've made an intentional mistake here. I've done one little tiny thing wrong. Something about my triangle. One more time. So the 5 will never be negative. The 3 certainly is, though, because I'm in quadrant 3. If you drew a triangle that wasn't in quadrant 3, I'm not going to say automatically that you're going to miss this, but it's a heck of a lot harder to notice that it must be negative if you don't do it in the right quadrant. Okay, as soon as we get all these, can we give ourselves secant and tangent? Find them for me real quick, and we have one more fun problem to do. So I'll give you a moment. Secant of this angle theta, we'll throw it on there, and the tangent of theta. Once you get it, check with your neighbor for me real quick, and then we're going to do a variation of this problem. I know that cosine, which is the reciprocal of secant, is AH, then it's HA, right? So secant is hypotenuse over adjacent. The hypotenuse, I'm pretty sure, is 5. the adjacent is -3, you will never see me write a -3 here. I hate it. I'm going to put it up here. Or in front. If you want to put it in the denominator, you can, but I'm sure I'll comment on it. Cool, cool? Okay, what about that tangent? Oh, -4 over -3, but what happens with the negatives? Perfect. Cool. We can see that with the triangle, if it's drawn in the right place, it will help. It's up to you if you're going to commit to that or not. Sweet. All right. I want you guys to try one more for me. When I talk, I assume that you guys believe like most of what I say, especially regarding math, especially. You should. I'm never going to intentionally lie to you. Sometimes I'll make mistakes or not say the whole truth. But I'm going to make a claim for you guys, and I'm not going to name this example yet. We're just going to leave it blank for a second. I'm going to make a claim, and I want you guys to determine whether it's true or not. Love it. I think that I stumbled upon something magical. If I take 1 plus the sine of theta, and I were to multiply this by 1 minus the sine of theta, and I was just playing around with the numbers, they seemed interesting. But what I determined, and I'm going to ask you guys to see whether or not this is true, I think I determined that this is cosine squared theta. Now, for this, we need to talk about the name of this example because there's something fundamental. Right now, I think this is true. The notation that I can use for that is this. Now, we need to be really careful about the significance of I think it's true, not I know it's true, because there's a difference. If I knew it were true, I could use the properties of equality, such as if this is truly equal, I could divide both sides by the same thing. But only if they're equal. That's a property of equality, which we don't know if they're equal yet. So, what I want us to do is we're going to see if we can't show that this is in fact true. And I'm going to say, let's verify this. Now, this will become a pretty large focus for us later in, I think, chapter 5. But right now, I'm not allowed to do I can't mess with both sides. I want us to try to transform one side into the other. And I don't care which side we start with. Between you and your neighbors, we'll just take a quick, verbal vote. We're either going to start with the left or the right. You get 20 seconds. Talk with your neighbors. Let's decide. Don't care which one it is. We'll see. Are we starting left or are we starting right?
I think the right. Split the cosine.
All right, number 12, you're the decider. I don't know who 12 is. Good choice. That's what I would start with. Okay, so I'm going to start with the right. Sorry, I'm going to start with the left, and we need to make it turn into the right. So I'm just going to write that out. It's up to you if you want to. Let's check if left, specifically the left side, becomes the right. Okay, now, in this, there's no necessarily obvious choice to make other than let's just see where the algebra takes us. We're just going to take a nice walk down the road. If we take a wrong turn, that's all right. We'll grab a bite to eat and keep walking. Not a huge deal. On the left side, Mickey, is there anything, forget about the right, if we just look at this, is there anything on this left side that you look at and go, hey, algebra, I know that you're telling me I should do this? And I know it feels weird and you might not even know what I'm asking, but if I give you this and said, do some algebra with it, or do some math with it, what is the first gut instinct that you might have? One more time? So you're thinking like terms to add or subtract, right? I like where your head's at, that you're looking for them, but I don't think I can add and subtract yet. I could multiply them though, that's what's happening, right? So let's use that F word and do it. When we multiply these out, 1 times 1 is 1, minus sine theta. plus sine theta. And what's my last term? I need a little bit more. You missed one thing. Love it. I would call minus, but same thing, right? Okay. Anything cool happen? They gone, right? They zero out. All right, so that means on my next line, and I'll just lightly cross so I can still see where it came from, I end up here. Gosh darn it, I was supposed to be at cos squared, not 1 minus sine squared. Hold on. Hold up here. I have a faint memory from a prior life that this looks like something. What's sine squared plus cos squared? I'm going to try it again. I want 100%. What's sine squared plus cos squared? 1. So if I wanted this to look like 1 minus sine squared, I'd just do this, right? And what do I just... Whoa. Minus. I just discovered that I could replace this with a what? Huh. Was it true? Okay, big check. I have no idea because I wasn't your geometry teacher. I'm going to leave a little gap here. Have you ever seen that? QED. Where? Definitely. In where in geometry? Oh my, proofs. We just did a proof. This is Latin for quadierat demonstrandum, that which was to be demonstrated. That's Latin. We just did a proof in here, and it was terrible, right? It wasn't terrible, I hope. I'll tell you, I don't usually use QED. There's a better symbol that's accepted in all mathematics. QED is fine if you want to use it. It's a box. Every proof that you ever do. I was lying to you, sort of. Proof. We just did a proof. Does this feel exactly like your proofs that you did in geometry? Easier or harder? Same thing, except I didn't make you do 2 sides of it. That's it. If the math is obvious, why I don't need you to justify it? I trust your math ability right now. Cool. Super challenging. Should we do one more? And by we, I mean I want you to do one more. Let's try it. All right. Let's get wild. Ooh, that one looks neat. All right, I've not done these, just so you guys know. Do you guys... Oh, I love it. Love it, love it, love it. Pick a number between 50 and 56. Huggins, anything between 50 and 56. Pick one more. Okay, pick one. I'm not going to make you keep doing it. You happen to pick the exact one and the one that looks exactly like the one that we just did. So we're going to go a little bit crazy with it. Do you guys agree that tangents are harder to think about than some others? What's easier to think about than tangent? Sines are way easier. And cosines? Like, those are way easier than tangents. All right. I'm going to use the angle beta. I want you to prove the following relationship. I claim that the tangent of an angle beta plus the cotangent of an angle beta. If you take all this and you divide it by the tangent of beta, if you do all this terrible, awful looking stuff, it turns out, I think, maybe, that it's cosecant squared beta. I don't know whether I believe it necessarily or not with good reason yet. I want to give you one little push. What side is uglier? Deal with the left side. Start there. Feels counterintuitive. Start there. I promise it makes more sense. Cool. Talk it out. I want you somehow to change the left side to the right side. If you want to take the sines and cosines routes, that's fine. If you know any clever algebra tricks that you've seen with stuff that's not this ugly, I'm also fine with that. Play around with it for a minute. I want all ideas. When you make a mistake, I don't want you to erase everything. If you get started on this problem and realize that, nope, I took the wrong path, exit. Like literally X on your page. Don't erase stuff. Try again. Do not erase stuff. You need to know what road was the wrong road. I'll give you a minute. Try something. That's the most important part. Here is that example that we're looking at. And I see like doing the same thing. Between this step and this step, there's a fundamental issue. And I know where your head's at, and I totally get it because you've taken a lot of classes in doing with math. Do we know that this is equal? Not yet. Can we use then the multiplication property of equality? No. When you're doing these, this is the step that the only time that you're going to write this equals something else. Everything else, you're not allowed to multiply both sides by because there's no both sides to multiply by. You can multiply by 1 if that means make something for you, but you will never write cosecant squared again until your very last line. You are showing me only this left side can be transformed into this. No allowed to do the same thing on each side of an equal sign because it's not equal yet. We don't know that. It's a weird jump from what you've ever done, but logically, if you call them the properties of equality and it's not equal, then it seems reasonable that we can't do it. Now, instead of this, when we split it up, something super, super nice happens. Do you guys want another moment to play around with it, or should we just talk through it together? One more minute? Okay, 60 seconds, do it to it. Is awesome. Here we go. I want to split this fraction. Can I write the left side of this expression as a sum of two fractions? It'd be tan beta over tan beta plus, what's my next part? Cotangent beta over tangent beta. Okay, this is the exact same thing. I just remembered or noticed that everything got divided by tan beta. Have I lost anybody yet? Okay, I'm going to do two steps in one here because one of them's super obvious, the other one's a little bit uglier. I can deal with this part no problem. What's tan beta over tan beta? 1, because anything over itself is 1. Okay, this next part I think is a little bit uglier to deal with. I don't like to have to think about cotangent divided by tangent. Now, there's a few different ways that you can logic this out. We could switch to sines and cosines. Totally valid. Don't really want to. We could. In my mind, I look at this and I see that I'm taking cotangent, and I'm just going to change the language. I'm multiplying it by 1 over tangent. Is that the same thing? Instead of writing cotangent divided by tangent, and whether or not I would write this depends on the day, but I think that this is the same thing. Yay? Except, yeah. Anybody lost there? Now, if only there were another way to more concisely or neatly write 1 plus tangent, or sorry, 1 over tangent beta. Oh my, reciprocal. That's just a cotangent.
Watch it.
Ooh, watch me. Now, I definitely would not show all these steps, but we're going a little step at a time. Is that really the same thing? 1 over tangent beta is a reciprocal of cotangent. This is that reciprocal identity. Well, this looks silly. Cotangent times cotangent. We'll get there. We're not quite there yet. You probably could be, and I would allow it. But this is just cotangent squared. Cotangent squared. Okay, so this is where we're currently at. Now, I don't remember them. I'm not even exaggerating. I only remember the one that I care about. I know sine squared plus cos squared is what? It's 1. So if I need a cotangent, I better divide everything by sine. So if I divide this by sine, and this by sine, and this by sine, and sine squared, I mean, and every time I do this in my head, and it'd be better if I could just memorize them, but they won't stick. Don't know why. That's a 1 plus cotangent squared. What's 1 over sine squared? Cosecant squared. Hey, this can be replaced with cosecant squared beta, which is what I was asked to show that it was replaced with. We done. Cha-da-ba-ka. Proof done. Don't lie. These are kind of fun, right? I think they're kind of fun. You all agree, right? Okay, no video record of that. These aren't even the fun ones. That's the exciting thing. We got a lot to look forward to. All right. Feel okay with that? All right. This is just the first introduction to it. We saw Identities for the first time yesterday. We lost my train of thought. I want you to make sure that you can do a couple, at least. They're fun to play with. On your homework from yesterday, you get to add some riddles, also known as verifications. What do they call it? They call them verify. We're going to call them proofs. Now, when you read the directions, they're going to say theta is between 0 and pi halves, so that you're guaranteed to be in quadrant 1. I didn't specify it there. Nobody had any objection with it, but nothing changes. All it requires, only reason we do that is to say, hey, if tangent happened to be undefined, we didn't try to deal with it. So here we go. I want you to add 50. 54 and 55. 3 riddles, 8 minutes. Have fun. The same as last night's homework. 287. So there's a whole section called verifying trig identities. It's 5.2. It's legit my favorite section of the whole book. I'm going to hook you guys up. The video's still recording. Don't. You know what? Should I show you the answers that they give me? We're in 4-3, right? Where are they? What numbers are these? 50? Oh, yeah, here's all the answers. Focus. It says answers will vary because everybody writes a proof differently. That's what that's the answers that my book gives me. Answers will vary. Because there's so many ways to do it, which is fun. All right, there it is for you guys. It's on the video, so if you don't take a picture, it'll be on YouTube for you at the end of the video.